everybody. It's just Greg and Keith and me.
Hey, Keith, Jim.
Hey.
Hello, how are you?
Good.
Waiting for summer and sunshine. I did IM with Keith about an hour, not Keith, with Kim about an hour ago, and he did plan to make it field questions on the Azure confidential containers and the CC policy stuff. I don't know, Jim, if you also talked to him.
No, I didn't. I did talk to Soma, but I think Soma pushed his presentation out to the following meeting.
Right.
Anybody else having a problem with the LFX interface to launch the Zoom?
I always have to come in as guest. I don't remember doing that before, but other than that, nothing.
No.
Yeah, same thing for me. I used to say that again, Keith.
It seems to work fine for me.
Do you log in as guest or do you log in with an LFX account?
I log in with a Linux Foundation account that is single sign-on with Google Identity.
Okay.
I had
I
to
did the
update
password.
my Zoom app. I was trying to launch the Zoom app, and then it would push me back to the.
Yeah,
Mhm.
when we moved over from regular Zoom to whatever this is now a couple months ago, I had to stop using the Zoom like progressive web app and instead just follow the link from the invite and do it in a browser window.
Yeah, I was able to update my app. It works now.
It also no longer integrates with our conference rooms like regular Zoom does, but I'll live.
All right, so I guess we got 2-3 presentations today. So we can give people another minute to kind of get quorum here. And see the presenters, Ken and Tyler.
Dan, you only got one character in your name today. What are you, like, logged in on your phone or something?
Well, it was what I was saying earlier that the LFX interface, it lets me log in, but then it doesn't launch Zoom. So then I have to log in as guest, and I was too lazy to retype everything.
Yeah. Fortunately, I can decipher D. I'm not sure everybody would know who that is.
I didn't notice that it adopted that from the login. Let me see if I can adjust that.
But it has your image, so which is interesting. If you're a guest, how does it have your image? Did you upload your image as part of your guest login?
Is that better?
Or again?
Okay, any openness before we get started, or we just go ahead and we've got a pretty full agenda with terms of presentations and a lot of times here. See, Ken's here. So if there any no other opens, I guess Ken, if you're ready to present.
So I'm kind of expecting people to ask me questions.
Okay, right. That's what's it.
Present.
Okay.
If we can all remember back all those weeks ago, I found my presentation, so I can present again if necessary. But if people have questions, then I can hopefully answer them.
I think it certainly would be helpful for me if perhaps you could, pick the one slide or something from your presentation, pop it up there, and just kind of 60 seconds help page us back into our head, kind of the topic, and that
Yeah,
would certainly
okay.
help me kind of get page back in any questions I had,
Let me see
if
how
that's
to do that.
possible.
If I press F5 here, and then
Is that April 9th?
and then
Yep.
how do I share from this machine? How do I share? Share screen. Which screens are going to share? Let's go share that one. Okay,
Got it.
so if we remember, it's all about this is all about execution policy within the confidential ACI product. So it's a bunch of Rego that is used to basically say what a container is prepared to do, given the control plane asks it to do something. And it's enforcement over. Oh no, it's not. That's weird. Okay, I mean, I have to press down arrow a lot. It's enforcement over things like sort of what devices can be mounted, environment variables, the command that can be run, and very much over the identity of the workload. So it uses the measurements of the various layers of a container to ascertain it's a genuine container. Then the interesting bit is you then get an attestation report, and in that attestation report is embedded a hash of this set of rules. This is the policy. So here's an example of policy, if you remember from before, and it does stuff like say, hey, that you can mount. Well, this is actually the rule that it operates over the policy. It says if the policy I'm being presented with, the input one, matches with the policy in the allowed list, then proceed. Basically, let's say allowed is true. There's a big complicated set of logic to evaluate all that. Let's go through all that. Then the hard bit is managing change. We have this idea of fragments, which I think somebody was interested in. So this is basically pieces of policy that can be kind of late bound. So here we're saying I've got a fragment. It basically it's got a feed, which is just a string, a name. By convention here, it matches up with where the container would be found, and it's signed by an issuer, and that's the DIDX 509 representation of basically a cert chain. And we trust that the issuer is only going to sign things that they trust. So we're saying we're deferring to the trust to this issuer. And it says, please give me the containers and the other fragments out of this policy document. And the contents of that is just another policy like the policy we saw above. And we have image attached fragments, which is in fact turned on now, which especially for Greg, which lets you say any given container can come along with a piece of policy that will automatically be presented, and if the rules let that policy in, then it will apply, and hopefully that applied policy will allow the actual container that's attached to be executed. And then there's standalone ones which are for handling pieces of infrastructure that might be a bit more static. Oops, somebody's starting a meeting. I should be in, never mind. There's various bits and pieces. I think that the fragments is probably the most interesting bit. I think somebody had questions about fragments. Silence.
Well, I have one question I have. Sorry, go ahead.
No, go ahead, Jim.
No, I was just going to say one question about just in terms of writing Rego scripts. So is the customer, the user, allowed to write any general purpose Rego script or and apply that to the OPA system, or is there some kind of pre-processing that limits the attack surface? Because Rego is pretty.
Okay, so well, the user, the person writing the Rego script okay. So the Rego script is the embodiment of the rules, and that is how the user expresses the rules. Okay, so there can't really be an attack from that direction, because at least not without using the fragments. I'll come back to that. So because this is authored by the user. Now it's authored by tooling on behalf of the user. But if they can put anything in here, they could put a thing in here that says just don't ignore all these rules, return true everywhere, right? And then it would return true everywhere. And they need to know that their rules are the right rules, and they need to be So that's a key. That's the basis of the trust relationships. Now, what we actually do is it's generated by tooling, and in the actual product we say we're only going to support the ones generated by the tooling, because it's once you start writing your own Rego here, it gets practically impossible to support. It's like saying, hey, you can just write your own code and we'll fix it for you later for certain arbitrary programming language. We do have the odd customer who does wild and crazy stuff. So we have a customer that says, if I'll run any container that's not privileged. Okay, and they're using that scheme in order to support sandboxing, where the payload container they don't know about, but they're enforcing it's not privileged and therefore hopefully won't escape won't escape their sandbox. And there's myriad things you could do in the Rego. And we chose Rego really because we started off with JSON ones, and we discovered very quickly that we had to sort of special case too many things in the JSON, and we were basically tending towards a domain-specific language expressed in JSON. And I've personally been down that road before, and we argued amongst ourselves for a bit, and we chose Rego instead. Is that enough?
Could you go into a little more detail on the image attached fragments or fragments in general? If you covered this in the last meeting, I'm not recalling.
No, I'm happy to talk about fragments all day long. Right. So this is one of the novel things. Right. So, okay. So we go back to the actual Rego. Okay. So this is a bunch of rules. Okay. And interesting rules, particularly interesting and obvious rules, are things like this container. Oops. Get my mouse on. Oops. Oh dear, I'm getting all sorts of alerts of secrets that come up. Oh, sorry. Okay, this container here. I have to stop that. Maybe I should quit Teams. Right, so we've got an array of containers. The first container has got a bunch of things that we don't really care about. It's particularly got a command. The command here is skr debug. That's all that's allowed to run. And it's got some rules about environment variables that are allowed, and these are kind of defaults. Pretty much everybody gets given these. It's got some layers, and these layers identify this particular container. It's one Parma Europe registry, whatever. Again, SKR 2.0 is allowed to run. This ID is just a label. The identity is checked against the hashes of the layers. Okay, so a bunch of other things, but they're less important, really. So this basically says you can run this container with this command. Okay, now that's all fabulous, except, well, there's more to running containers than running the payload container. Right, this is all fine, but up here we've got another rule. It says I've got a fragment that's called the ACI CC infra fragment. And inside of that fragment, there's a bunch more containers like these, which are the sidecar fragments that the customer is prepared to run. Now, it's unfortunately a one-size-fits-all for this. If you're going to have some sidecars, you're going to have you have to have all of them. Well, you don't have to have all of them. You could put the rules explicitly in here, but it would be fragile. I'll come back to that. So this says any container whose feed is this, and this is part of a COSI sign 1 document, the feed part, and is signed using this issuer, which basically means the root certificate's hash is this, and the leaf certificate's extended key usage is this. Okay, and we guarantee the people that issue our certificates guarantee they'll only give that signing to a particular entity, which is the ACI team that are making promises about the legitimateness of their sidecar containers. So, and then it says, well, we'll let in containers and we'll let in fragments. And so if this fragment refers to other fragments, this rule will let in those other fragments too. We could take out this fragments part here, and then it only adopts containers that are inside of that fragment. And so by having a rule like that, carry on.
Could I just, yeah, so the top, I don't know, field on there is fragments, and then you've got fragments within fragments. Is that what that means?
You can have fragments inside fragments, yes.
So what is the outer thing defining there?
But this part, oops,
Yes.
sorry. Okay, so this is the fragments rule, which is a set of rules. There's only one, and it says a fragment of this from this feed, i.e., with this identifier, signed by this person, can bring in containers, i.e., rules like these, or more fragments. So it can add rules like this rule to allow in some other fragments. So the degenerate, so a sense, you could, for example, say that the fragment that's got this identifier is in fact simply a list of half a dozen, say, other fragment rules like this rule that specify particular other fragments with different feeds. So they might be feeds like ACI/ECI managed identity, okay, or ACI shared storage or something like that, okay, and that fragment, the meta fragment, just was a bunch of references to other fragments.
Hey Ken. Okay. Can I try one thing out from a terminology perspective to see if I understand things correctly and perhaps clarify for folks? When I hear the term fragment, I think that encompasses some rules. And I think as used here, and correct me if I'm wrong, but I think as used here, fragment is really metadata about a fragment. It is saying this, it's the thing that defines an indirection. It's saying, I trust this entity, is this using the term, using the tag issuer with this did X509 thing, to define policy of these flavors. That's under includes. It can define containers in this case, or other fragments, yet more indirections. But the fragment, like this collection here under fragments, it's not actually anything that's it's not the it's an indirection to get to more policy that says things like trust these sidecar containers and so on. So perhaps from a name perspective, if I were just imagining how I'd name this in my head, I might call this, fragment authorities or something like that.
So basically it's the fragment rule, which defines the set of rules which contains the rules that allow fragments in, the same way as the containers one below is the set of is the rules that allow containers in.
Yeah, maybe it's just me tripping up, but when I look at this and I think of fragments, I think of subsets of this file. So I think, oh, containers, that whole thing might be a fragment. And
it could be a fragment, and indeed
but it's not under that fragment syntax at the top there. I would never put the actual expansion of container. What I put under fragments on the top here is an entity, an issuer that's trusted to create separate, to create separate signed policy, and the allowed top level tags there would be like containers, for example. But
I can see how you're thinking about it. The way I think about it is that I've got a containers rule, and it's a list of allowed containers. and I've got a fragments rule, and that's a list of allowed fragments.
Yeah, I can parse it all together.
All right.
So thank
But
you.
anyway, the purpose of this is to give us basically indirection in the policy. So what happens is that the reason we needed this is that these infrastructure sidecars, which the ACI team provide, they could change. But we really do want this policy to be stable, right? So that the key release policy in the HSM that's eventually going to hand over the keys is also stable. And that gives flexibility to the team that operates the system to update their sidecars without having to say to all the customers, hey guys, we're going to update our sidecars now. Can you please add this new rule that lets in the new sidecars and delete the old rule, and so forth. Now, of course, it expands the trust enormously, but it expands the trust in the control of the customer. And so the customers, if they want to use these feature facilities offered by ACI, such as the managed identity and so forth, then that's what they have to do. Keith.
So the fragment that's being trusted here by this fragment rule, where does it come from? Like, is that feed something that like this the evaluator of this policy is going to like download, or is it attached to something else? Is it fed in through an API? Like, where does that come from?
Right. So that feed, although it looks like an address, is literally just a string. Okay, and it's kind of confusing, but it's just the way the convention arose. So in that particular one, because it's the infrastructure one, is provided by essentially magical means, out-of-band means by the platform. However, there's the purpose of the image attached ones are that when you have your image in your repository, you can use ORAS to attach artifacts to that image. And if you attach the right kind of artifact to your image, it will be presented as a fragment when you specify the image to be loaded.
So if the typical case is that fragments are attached to the images and those fragments have the policy that trusts that image, is that functionally any different than just having the image itself be signed by the issuer? Why have the indirection of policy there?
So so whilst a signed image has a bunch of information in it, we have a couple of problems with that. The first problem is that the signed images are typically have that manifest contains hashes of some tar files, zip tars, and so forth. And if we were to consume those in the TEE, we'd have to do all the untarring and validation of those images inside of the TEE. And we don't do that. we do all that out in the untrusted world. And in fact, we can cache those expanded layers as we see fit in our cloud infrastructure.
If you're not verifying that in the TEE, how can you trust it?
So those layer hashes are Merkle tree root hashes. So what we do is we construct a DM Verity, in fact, Merkle tree for each layer, and we store its root hash. So we can guarantee by applying, we can guarantee when we mount the thing, we provide the root hash, and we know therefore all the blocks must conform to that root hash. So we don't have to scan the entire image inside of the TEE, which tends to be slightly underpowered compared to a full-blown computer.
I see.
Yeah, and that also, it turns out that most containers you never load all the blocks. So if we can avoid having to hash the whole thing, apart from the practicalities of reading all the blocks into memory. And then we'd have to construct a Merkle tree, because we're not going to store all the blocks in memory. You'd have to read all the blocks and write a Merkle tree, and then do what we do and mount the Merkle tree. That's one reason. And the other reason is, well, there's a lot more to it than the stuff that's stored in there's more to it than the stuff that's stored in the manifest. So how you invoke it, what the allowed rules are, and so forth. They are related, but they're not identical. Some of this stuff is validating things that come from the control plane and are unique to particular instances of using a thing. And so we give people the ability to do that. So you could imagine replacing the layers with like the hash of the manifest, and then checking the signed manifest. But until we can extend manifests to keep this kind of root hash type information for validation in it, we can't avoid all the stuff being in here.
So when you add a layer, are you doing that after checking this updated policy? Because my understanding is that policy is evaluated on evidence as it's collected. So if you have secrets already released, and then you try to change something, and then that secret gets leaked before the policy says, oh wait, no, that change was not allowed. How do you avoid that?
So we don't let anything. Right, we won't mount a container unless we've checked all the layers match. Okay, and its command line matches. So if we know are you asking a question about what happens if the fragment allows in an exploit, or are you asking about how do we avoid exploits in the first place?
It's adding a layer or an image, whatever you're calling it, before checking policy.
So what happens is the host side offers layers individually to the TEE, and the TEE evaluates each layer against policy as it goes along. So it will not mount a layer whose root hash does not match an expected root hash, and in the right order.
So that goes to my question with the layers you have here are not the normal like container layer digests. Those are the root hashes of the file system in the layer.
Yes.
I see.
So otherwise it's very expensive to start up. We did try it. It wasn't good. And this allows for reuse and fast restarts, and generally not having a bunch of painful performance issues.
Is this policy being evaluated inside the TEE or a verifier service? Oh.
So if I go to one of the other diagrams, so this is kind of the evaluation thing. So the shim is the host, the security policy is a piece of code inside of the UVM, and then it's you get a request to do something, and then that's fed through the policy, and then a decision is made and the response thus made. So if I come along and I say, please can you mount this layer whose hash is 1, 2, 3, 4, comes in, gets evaluated against all that policy in the previous in here. And eventually we get an answer out that says yes or no. Okay. And of course, the response is handled. It doesn't trust the host to stop. It refuses.
Quickly, just to recap, I think what helped, if I'm understanding correctly, what helps me understand the distinction between what I was asking and what was being said here is like the containers that are being run here are not just like off the shelf normal containers. They have to be specially built so that every layer has a DM Verity, Merkle tree embedded in it, and that is what's being referred to instead of the normal like layer measurements.
Well, there's yes and no. So they are entirely normal off-the-shelf containers. There's tooling at policy generation time that will go and work out what the Merkle tree is, and that's the root hash. And then when the container is deployed to the node, the same operation is done on the node, or it may have been cached already somewhere else. There is some stuff to do that. So it's delivered to the node or expanded on the node to have the Merkle tree. But it's coming from a container repository that's a regular container repository. It could be Docker, it could be yours, it could be Azure's, it could be anywhere, just normal.
So you're still doing all of the measurements in order to build the Merkle tree. Just you're doing it outside the TE, but you're still doing it at lunchtime. Then.
We might be doing it at lunchtime, or we might have done it already in good time. There's caching opportunities, and there's a lot of reuse availability for this. So, for example, all these sidecars will be the same on all instances. If you've got 10 container groups running on a node, then that's all the same, and they'll not be done twice.
Right, makes sense.
If imagine you've got 10 containers that are all Ubuntu 2404 or 2204 or whatever as their base layer, that's all the same. So you do it once.
Are you going to go into the signed fragment format? Because that sounds very similar to the signed reference value format that we're working with in CoRim. And
okay, I can talk about that. So what it is, these things are they're cozy sign one things, and they are just the container for the thing is just a cozy sign one document with a DIDX 509 issuer. Got some code if you like that you can play with those with.
But the payload is Rego?
Yes.
Okay.
So if you put in the chat the thing that you were talking about that might be like this, then I probably want to look into that. You can tell me more.
Do I need to write a fragment for each container, or do they transcend the containers?
So what happens is in the practical world is you write your ARM templates, which is the way you describe to Azure your resources, and it says I want these containers, please, and then you offer that to some tooling, and then the tooling generates the policy, which is the policy for that container. There's some other tooling or options to that tooling where you can say, hey, here's a container identified by its path in container registry. Please generate me a fragment to allow this policy in, this container in, and then you can then store that with the container, and then you can say write fragment rules that allow that another payload to take that container.
Are the fragments the only way to address that kind of policy association? It seems like.
No, so the primary way is the policy like I've shown above. The fragments are sort of a secondary way to allow for some flexibility and serviceability. So this generally you would create one of these from the description, the job description, which is if you're Kubernetes people, you think of it as the YAML, right? In this ACI case, there's a JSON description of the job. and that lists which containers are in your job. It lists various properties of the containers and so forth. And so then we can generate you a policy from that, and then you use that policy in your key release, or the hash of the policy in your key release. So the hash of the policy gets embedded in the AMD SMP hardware's it's a host data is called. It's a immutable field. So that's represented in your attestation report. So you can tell that the payload of that particular utility VM was conforming to the policy that you expected.
So with each fragment, if you go back to your diagram, I only need one fragment for all my VMs, but does each user or each consumer have their own?
So can I just inject one thing here, just to make sure we're on the same page? I think fragments are optional. They allow indirection. They allow delegation of trust to another entity, is how I understand them. So they're not required to be used. They're policy about who do I trust, not policy about what's allowed to be loaded in the confidential container. And so they're optional if you want to delegate trust to other entities. Is that accurate, Ken?
Yes. So for a good use case for fragments would be to say, hey, I've got this job and it's going to use the Triton inference container from NVIDIA. I'm prepared to trust NVIDIA. I'm not going to audit every version of the Triton inference container. So if NVIDIA sign a fragment that says this is a true NVIDIA inference container, I'll trust that, and then they can service their container, and my code will still work.
Yeah, that was helpful. Theoretically, each consumer may define their own fragment because they may trust different issuers.
Well, they would have different fragment rules to allow in the different issuers and the issuer feed pairs. It's quite important that they're issuer feed pairs, because I might want to allow in the regular Triton inference container, but I don't want to let in the also signed by NVIDIA Triton Super Debug verbose one that prints everything out as it goes along. Okay, so it's important to have the pair to establish the trust. Now there's a degenerate case, which I think Greg is thinking of using, where all you have is just the fragment rule. Your policy is entirely a fragment rule, and it says I'm prepared to trust this thing that I signed myself, and that keeps the host data stable. And then you can re-release the thing you're going to run 10 times a minute, and as long as you release a new fragment you're prepared to trust, then you're good.
Is the
I
fragment
think
already part of Rego, or is this something that you added?
It's all added. It's just the Rego is really, we should think of the Rego as just like a programming language.
It's subturn complete, so I'm just wondering like what expressiveness allows you to check like a cosine one and then unpack and reify into Rego policy.
So what happens is what happens is, going back to the presentation diagram. So what is, we determine that there exists a fragment by whatever means. Either it's presented to us out of band, or we get it because it's attached to some container that we've been asked to load by the host side. And then we say, okay, in order to consume this fragment, we have to offer it to the Rego engine to evaluate whether or not it's acceptable to these rules. Okay, but first we're going to say we can take apart the cozy sign one in Go code, I think it is, and check that the issuer that fragment has and the feed that fragment has matches up with the payload of the container. So that basically that the certificate chain within the COSI sign1 document matches the issuer. And then we'll say to the Rego engine, hey, can you evaluate whether there's a fragment rule that allows in a fragment whose feed is this feed, whatever the feed is, and the issuer is whatever the issuer is, and has an SVN of this number. And then the evaluation part is then done in the Rego. There's obviously a bit of glue between the, between the Go and the Rego to appropriately mangle the data structures. But it is moderately straightforward. And that's equivalent to the same thing where a container comes along and we go, okay, we're being offered a container and it's got this layer #123 and its command is skr debug. Is that allowed? It's the same evaluation process.
So you could have many fragments and many trusted issuers, right?
Yes.
And if I throw my container to the, am I stuck with all the fragments that were issued before? What if I don't trust? What if I don't trust one?
So if you don't, so you can specify an SVN. So suppose there's a compromise in version 1 of that ACI CC info fragment, then and we decide we don't want the old one, then we can up the minimum SVN to an appropriate minimum SVN. But if once you decide you're going to trust some fragments, you've decided you're going to trust some fragments. It's a feature.
Well, I think of just bubbling up a level, make sure we're on the same page. This is all this is the underpinnings of this feature in Azure called Azure Container Instances, and specifically confidential containers in Azure Container Instances. And you, in order to work with one of these, you as an Azure customer will create one. You are in full control of the policy for your confidential container instance in ACI at all times, right? So you can define what's here, and it'll always be honored by the enforcement engine that Ken's talking about. So questions about how many fragments are trusted and what control do I have, it's ultimately you as the owner of the container and its associated policy. There's some tooling to help automatically create the Rego policy based on the containers that you're loading into your container group, for example. But ultimately, you're in control, and even though it's not supported, I suspect you can hand twiddle, what's generated by the tools, and in many circumstances, it'll work. So, and I think what I heard Ken going into was some of the details of how, given what are some of the features in terms of when you have a fragment that it can control what specifically it evaluates as acceptable or not, for example, based on the SVN. I'm not sure if you were thinking about that kind of permutation or just the higher level, like, am I in control of my policy? And there's a little bit of, like Ken has talked here about, this default fragment that's put into, I think, all policy by the tool, and maybe I got that wrong, Ken, but there's a set of sidecars that are used in the system commonly. And so the ability to put the fragments in that identify those trusted sidecars is kind of automatically put in there in many or all circumstances. But that's separate from, that's kind of like infrastructure to just allow the ACI confidential container technology to work. All other fragments are things that, essentially reflect if you want to use fragments and your definition of what's trusted in your confidential container environment.
So that makes sense. So fragments are used today to trust sidecars?
Yes. So this particular example, sorry, I accidentally covered all the task manager. This particular example is the so-called infrastructure sidecar, okay, which is a kind of catch-all collection of features that the customers value for this particular particular product. But it's basically an indirection mechanism, and you can indirect for anything.
Okay, so what are some other examples? Of when
Okay, so
yeah.
so right,
Do you want me to explain my example for MAA?
yeah, you do
Yeah,
your
that was a
example.
good one.
So if we take a step back and think about a relying party that's trying to determine trust, whether it trusts a particular confidential container environment in ACI, it's going to have some attestation evidence, that's available for that environment. And part of one of the measurements of that attestation evidence is the hash for what we're looking at here, what's on the screen. And if imagining a relying, if you set up trust in a relying party, and if they have to basically change the value they trust for the hash of like this policy of what's allowed to run there, every time you like do an updated container, perhaps with current security updates and so on, it's like could be happening frequently, right? And so for some of the work we're doing in the Microsoft Azure Attestation Service, where we're using this technology, we recognized that the measurement of the policy is critical for relying parties to trust the code running in the confidential container, in this case, the Microsoft Azure Attestation Service. And if we tell all relying parties, hey, check this web page, at least once a day or once a week, for an updated hash for the policy, because we deploy once a week or what have you. That's not really scalable. So it's imperative that that hash value remain constant. So what we've chosen to do is kind of like the degenerative extreme. There is nothing in this top level policy other than an indirection to a trusted entity, a particular signing key that only our team has access to. And so then a relying party for MAA basically has to say, I trust, if they want to, trust us, the way they would mechanically express that trust is they trust our signing key and our hygiene and managing and using it and so on. And then they also trust a policy that's, static and remains, static forevermore, that says, anything signed, any fragment, I guess it's a fragment, any policy signed by this fragment identifier, this issuer in a fragment, is policy that I trust, and I know that the MAA team is only signing, let's say, for example, definitions of containers that reflect true builds of the MAA service, for example. So that's another reason is to minimize the churn for relying parties who basically they determine trust. Like they say, here's a confidential container environment. How do I know if I trust it? Well, if their trust is expressed as, oh, these hashes in the container layers, for example, or, oh, this was the command that was used to launch. It's like, that's kind of brittle, and over time those will change. So to allow that policy to be very static, using the indirection like, oh, there's a trusted entity, and as long as that entity doesn't change over time, the policy doesn't change over time. The relying party authorization policy can remain static for that amount of time.
Is it generally the case that the customer's container is making API calls to the sidecar in a way that it's explicitly aware that it's depending on that?
Yes and no. So I'll give you a link, I think, to the so-called confidential sidecar containers repo. And so some of those are containers which are sidecars in the sense that they're not the payload container, which we used for a demo with NVIDIA again, where we'd have the Triton, an inference container getting given data via some sidecar relay, but which is doing decryption and key release of a pile of ML data. Okay, so you'd have, imagine that you've got an encrypted pile of data somewhere in some file store somewhere, in Azure, and the sidecar basically makes it look like that data is decrypted and local to the inference container. Now, there were no APIs involved in doing that. It just turns up in a place, and that place is specified by some environment variables that are presented to the sidecar container. Now, so that's kind of one piece of like trying to do it in a transparent way.
Hey, Ken, can I ask a couple just clarifying questions? So are sidecars, my understanding is sidecars are not required for any particular scenario. Customers can choose to use sidecars or not. But on the flip side, I think that there's sidecars that have been developed by the community, by folks at Microsoft and perhaps elsewhere, that provide some common that support some common scenarios, such as unlocking, encrypted disks and some of the things you're talking about. But it's not, sidecars are not required. There's essentially there's an emerging set of tools to help you work in a confidential environment that are packaged as sidecars. But it's not necessary you use these tools. It's not necessary that you use the sidecar design pattern if you choose to implement, shareable code yourself.
Yeah. So basically, the container community likes, I don't know if they like it, but they do this a lot. So they compose applications by putting several containers in the same place and having them cooperate in this, they're all in the same pod. And so you get things like Envoy, for example, which is a container, sidecar container, and provides, TLS termination and encryption and so forth for network connections. And so that's kind of like a common, as you say, it's a common pattern in the container world. You could equally well do this by piling all the code into your own container and having libraries to do these things. And that would be a perfectly fine plan too. But that's not what people seem to do.
That helps. So maybe just thinking about how things work in Google Cloud, is there a similar set of Google-specific sidecar containers that would be maybe analogous to some of the Azure-specific ones that Ken mentioned?
That's hard to say. I can't tell you the answer to that. Now, we are working on some stuff that came from Google.
And that wasn't directed at anybody at Microsoft reflecting their own knowledge of Google Cloud. Since we've got a few different vendors, kind of looking for the commonality is interesting. So it looks like Deanna dropped something in chat there, but don't expect anybody to necessarily know off the top of their head. But I would be curious. Like Envoy is a good example of a general purpose networking asset that people might use.
So you get quite a lot of stuff in the Kubernetes world where you've got different pieces inserted. I don't know whether I don't know. By and large, okay. So one of the reasons that we definitely have to have it for ACI is because the environment is slightly odd compared to maybe a Kubernetes environment. And so it has to do some things where there's a bit of sleight of hand that has to happen. And so they're kind of an implementation artifact. Now, you can turn them all off, but you lose some features. But But that's the world we live in.
Okay, anybody on the Google side have any thoughts on like GCP specific sidecars that people would encounter?
We have a sidecar for keys and for disk unlock. More are coming, I imagine. I'm not involved with those teams.
Okay, thanks.
So is that a sidecar that you'd have in confidential spaces?
Not necessarily. I think the confidential hyperdisk is something that we offer in CVMs outside of confidential space. Because confidential space doesn't support SetSMP at the moment.
Okay.
So I'm running this in ACI, right? Why do I need to trust the ACI? I know it's smart, but
So you don't have to. You can turn off all the features, and you can say, no, I'm not going to trust any of your code, right? But there are some features you won't get. Okay, and so for example, you won't be able to have provision a managed identity to your container group without having taken their sidecar that provisions managed identities to your container group. Now, that's all about, I'm afraid that's the way it is. This is kind of implementation detail of this particular platform. And so we needed to provide a system to let people have the facilities in a serviceable way. And you have to make choices. If you want managed identities, which you may want or you may not need, then you have to accept that there's some void and some trust.
okay. So the way this is written is anything signed by Microsoft with that X59 or X509, I trust.
No, not quite. Anything signed by that X509 and it has this feed.
As the what?
So has the feed field of mcr.microsoft.com ACI CC infra fragment.
Okay, so what examples of that would be?
I think the goal here is to qualify the trust not to all of Microsoft, but to the subset of Microsoft that's basically managing this part of, hopefully this part of the code base. And
right.
It's.
I like that. I think that's good. But tell me what are the feeds and what are their purpose? Because if I don't trust it, what do I lose? Right. So if I don't have this fragment, I lose a bunch of ACI capability, don't I?
Yes, you do. you lose the managed identity stuff. You lose some. I forget now. There's a whole list. There's about 4 or 5 different features, which are things that if you go to create your ARM template to say I want to take advantage, you probably lose being able to mount certain sorts of remote disk. What you'll tend to lose is things that involve interaction with other Azure resources. So if you're just some server that's doing something straightforward and isn't relying on being highly integrated into the Azure ecosystem, you probably don't need any of them.
Okay, I see. Is there a way to get a list of those things so I can make that decision?
Well, you kind of opt into them when you start adding features into the ARM template. If I'm sharing the screen, you can see. Then there's this ARM template thing, and you get to basically enable various features in here, and some of them are implemented in terms of these sidecars. I don't have a to-hand list, but there's like a handful.
Okay, tell me what to look for real quick. I was looking for feeds, but I don't see feeds.
No, because the feeds, these feed things. Okay, so feed is a field in. I think it might be a well-defined COSI sign 1 header field, and that's why we're calling it feed. It's just a label really,
Okay.
and it's all signer stands behind. The stuff like if you start mounting volumes, if you want to mount a Git repo, anything that's going to have to be implemented by adding code. Irritatingly, there's a bunch of them that are in fact like one page of bash script that do things that are essentially like, oh, I'll just set up the routing, the IP tables a special way, but we've not managed to influence the product teams to completely get rid of those things.
Hey,
But you
just
don't-
real quick, guys, time check. We're at the top of the hour here, so.
Anybody who's got further questions, feel free to ping me an email, and I'm happy to talk about this really all day long.
Yeah,
it's just
good discussion.
making things.
Yeah, we had other couple of topics to discuss today, but the presenters weren't here, so went ahead and let that discussion go on. So it's pretty productive. But we are at the top of the hour. Thanks, Ken, and everybody for the active discussion.
Yeah, thanks, Ken and everybody. That was very invigorating.
Yeah. Okay, I guess just from the clerical part of the meeting, any volunteers for the chairs for next meeting?
Hey, I just want to say I got pulled away. That was I appreciate that explanation. Thank you so much.
Yeah, well, if you didn't hear me say it, please, anybody that wants to drill into any of this, ping me on email, and I'm happy to chat to people. We think we've come up with a scheme here that's a good scheme, and
I wanted to say this is great control, very positive. I did kind of like to go back to the lady's question about it. It is executed outside of the TEE, I believe. So I don't know. Maybe that's not an issue, really.
What do you think's executed out of the TEE?
Oh, I mean, all this policy checking and all that policy is written.
That's inside the TEE. It has to be.
Oh, okay. All this is inside the TEE?
Yes.
I don't think it has to be if you're using attestation tokens.
Well, how am I to check whether or not if I want to say check if a signed thing, maybe a container or a layer or whatever, matches my rules, I need to trust who's doing that check, don't I? That has to happen inside the TEE.
You trust remote verifiers by using the entity attestation tokens, following the RATS framework.
So I claim they're trusting me. I don't think I'm trusting them. I'm proving to them that I'm trustworthy with their secret.
You are proving to them what your attesters say the state is, and then you trust their policy judgment with the attestation token claims.
So, okay, but if I go to a relying party with some evidence and they decide to give me a secret, they can clearly lie to me about that and give me the wrong secret, and I'll have no idea. But they're having to verify if I'm trustworthy as the TEE, I claim. So the contents of the tokens is just a representation of that, I think. So
right. I'm just saying that this REGO evaluation does not have to come from the TEE. You can delegate that to another authority that you trust.
I see. Okay, so you could say you could evaluate the relying party could evaluate the REGO. I think that's impractical.
I'm not saying that either. I'm saying that the Rego can be evaluated in a verifier service.
Yeah, I think that
So-
the TEE role here would be to collect the evidence, right? That would be evaluated by the relying party. But the TEE would either have to evaluate the policy or generate the evidence to allow the relying party to verify.
Right. So the TEE would be saying, "Hey, the host gave me this layer to add in policy. Do you say that's okay?" And that policy service can say, "Yes, here's the token with the claim that says you should accept it." You don't necessarily have to run the Rego evaluator in the TEE.
I think you'd find it be extremely expensive to not run it in the TEE, because you're going to these in our case, we've got a lot of micro operations, and so we would be extremely busy to keep going off the box to evaluate whether or not these operations were allowed, and in fact it's stateful as well. So I don't think it's practical to do this other than on the box in the TE.
Yeah, I need to drop. So I guess continue to discuss.
Yeah, we can continue. So that this particular argument about where you do the evaluation of your Rego or whatever, I think does lead into a whole particular set of conversations around how things might be done. And if you go and look at the CATA-CC people's approach to this, they seem to be with we could do the policy evaluation in the relying party and defer all the complexity to the relying party. But I think it's a mistake.
I mean, when I'm thinking about the teams that are responsible for managing change policy and how that's evaluated, they're far removed from the operational aspects of deploying individual workloads. So you would still need to defer to a change management service to say, "Hey, is this change okay?" Rather than saying, "Okay, all of the change management logic now needs to be delivered in every workload."
Well, if that becomes a problem, so that's a kind of user serviceability problem. That then the solution in our system is to make that when you deploy the new container, you deploy with a signed fragment, and you have a policy that just accepts whatever that according to if it's signed by the right people and it's got the right feed, then that's good enough. And then you associate the change to the policy with the change to the container.
I suppose that's fair enough.
Yeah, I mean, what we discovered is we've got, and this is why we have the infra thing, is we've got kind of three sorts of fragments. We've got like stand up ones that handle bits of the infrastructure we're running in. We've got ones which are like provided as by the customer as a kind of secondary version of the policy. And then we've got ones which are associated with particular containers to say, hey, this is a good enough container because it's signed by Bob, called X, Y, Z, Z, Y, or whatever. And we think in the combination of those things, we can make things which work and are serviceable. The project did have this bit in the middle where the serviceability people came along and beat us up, because before that we had everything a bit too fragile. So we believe, but of course we could be wrong, that we have it mostly covered, if not entirely covered. but please feel free if you want to talk to me some more. I'm very happy to continue with these things.
Okay, thank you.
Thank you very much.
Bye, everyone. See you in a couple of weeks.